Welcome. My name is Bob Tickleman. I'm a Microsoft technical trainer, and I'm excited to be your guide to this delivery of what you want to know when you want to know it. In this module, we'll explore continuous delivery, or CD, and its benefits such as accelerated release cycles, increased resiliency, improved collaboration, and reusability. We'll look at continuous integration, or CI, and its relationship with CD. We'll look at infrastructure as code, or IAC, and its principles. We'll apply CI/CD practices to IAC deployments and progressive exposure techniques in continuous delivery. Additionally, you'll be introduced to GitHub Actions and its components, including how to create a GitHub action workflow to support implementation of CI/CD. Let's get into this. Continuous integration, or that CI, and the continuous delivery, CD, are closely related DevOps concepts, representing two distinct stages of the software delivery process. As you know from the module, Develop with DevOps, the purpose of CI is to build and test software artifacts. CD automates the process of delivering these artifacts to their intended recipients. By implementing CD, organizations are able to eliminate the manual efforts involved in application deployment. Continuous delivery is a software development practice where code changes are automatically prepared for release to production. It builds upon continuous integration, which is the practice of merging all developer work copies into a shared branch several times a day. The main concepts of continuous delivery are the automated testing. This ensures that every change to the code base is automatically tested and can include tests like unit tests, integration tests, and end-user tests. CI is where every change triggers an automatic build process, ensuring that the software can be built from scratch at any time. Deployment pipelines are a series of automated processes that take code from version control through to production. This includes building, testing, and deploying the code. Environmental parity ensures that development, testing, and production environments are as similar as possible to avoid issues that only appear in production. Version control is where all code changes are tracked in version control systems, allowing for easy rollback if something goes wrong. Feedback loops are continuous feedback from automated tests and deployments. This helps developers quickly identify and fix issues. Microsoft provides several recommendations for implementing continuous delivery effectively. Using Azure DevOps provides a comprehensive suite of tools for CI/CD, including Azure pipelines for automated builds and deployments. Implement shift-left testing, which is covered in the Develop with DevOps module in this learning path. By moving testing activities earlier in the software development lifecycle to catch defects early, reduces the cost and effort required to fix them. Automate as many steps as possible in the CI/CD pipeline to reduce manual errors and increase efficiency. You want to utilize deployment pipelines to automate the deployment process and ensure that code is always in a deployment state. Ensure that your development, testing, and production environments are as similar as possible to avoid issues that only appear in production. While continuous delivery and continuous deployment are often used interchangeably, they are distinct differences. Continuous delivery ensures that code is always in a deployable state, but the actual deployment to the production environment is a manual step. This means that the software can be released at any time, but a human must approve the release. Continuous deployment goes one step further by automatically deploying every change that passes all stages of the production pipeline to customers. There is no human interaction, and only a failed test will prevent a new change from being deployed to production. Regardless if you're using physical infrastructure or virtual, on-premises or cloud-based, your infrastructure requirements are very likely to be able to be deployed and maintained through automation, thereby supporting infrastructure as code, or IAC. Infrastructure as code is an integral component of modern software development and operations practices. It involves the use of programming methods to provision and manage infrastructure services. Version control. IAC defines infrastructure components including compute, storage, and network resources by using code. Such code typically resides in a version control system, which facilitates tracking changes to infrastructure in the same manner as tracking software versions. Declarative syntax. IAC relies on declarative syntax in order to describe the desired state of the infrastructure. This contrasts from more traditional imperative syntax that involves writing code that defines a step-by-step procedure leading to the state. The declarative approach tends to be more efficient for many reasons. For one, it relies on the intelligence of the platform hosting the infrastructure components, minimizing the possibility of programming errors or inefficiencies. In addition, it ensures idempotence. This term designates the characteristics of an action where the outcome is always the same, regardless of the number of times that the action is performed. Since the declarative syntax describes the end state only, using it guarantees that each code execution will always yield the same results. This ensures the consistency of the target environment and precludes the possibility of unintended side effects of intermediary changes. Automation. The use of code facilitates automated provisioning and configuration, enhancing efficiency, consistency, and scalability. This also eliminates the potential impact of manual errors. IAC can be and is frequently used to integrate with CI/CD pipelines, yielding a comprehensive software delivery strategy by combining infrastructure provisioning with application build, test, and deployment into one continuous, fully automated sequence. Reusability. IAC promotes the use of reusable code modules in accordance with the best programming practices. This facilitates development of software libraries consisting of standardized infrastructure building blocks that can be shared across projects. As a result, organizations benefit from increased consistency, simplified maintenance, and minimized duplication of effort. Progressive exposure techniques in deployments help manage risk and ensure smooth rollouts by gradually exposing new features or changes. We'll cover 4 main techniques of blue-green deployments, dark launches, feature flags, and deployment rings. Blue-green deployments involve running 2 identical production environments, referred to as blue and green. At any given time, one environment, let's say blue, is live and serving all production traffic, while the other, green, is idle. When a new version of the application is ready, it is deployed to the idle environment, in this case, green. Once the deployment is verified, traffic is switched from the blue to the green, making the green the live environment. This approach allows for quick rollouts as well as rollbacks if any issues are detected. Imagine if you're deploying a new version of an e-commerce website. You can deploy the new version to the green environment and run tests to ensure that everything works correctly. Once verified, you switch the traffic from blue to green. If any issues arise, you can quickly switch back to blue, minimizing downtime and impact on the users. Dark launches involve deploying new features to production in an inactive state. These features are not visible to end users until they are explicitly enabled. This technique allows for testing new features in a live environment without affecting the user experience. Typically, feature flags are used to control the activation of these features. Suppose that you're adding a new recommendation engine to your streaming service. You deploy a feature to production, but keep it inactive. You can then enable the feature for internal testing or a small group of beta users to gather feedback to ensure that it works as expected before rolling it out to all users. Feature flags, also known as feature toggles, are a technique that allows you to enable or disable features in your application without deploying new code. By placing conditional statements in your code, you can control which features are active based on configuration settings. This approach provides flexibility in managing feature rollouts and allows for quick rollbacks if needed. Consider a scenario where you're introducing a new payment method in your app. You use a feature flag to control the availability of this payment method. Initially, you enable it for a small group of users to monitor its performance. Once you're confident it works well, you gradually enable it for all users. Deployment rings involves rolling out changes to different groups of users in stages, starting with a small group and gradually expanding to larger audiences. This approach helps identify and address issues early in the deployment process, reducing the risk of widespread impact. At Microsoft, we use this all the time before we release code to our customers. One is referred to as dog food, where we can sign up to run early releases of software on our corporate devices. Before we release it to the public, which we call GA or generally available, there are customers that have signed on to evaluate it in their environments. Progressive exposure techniques like blue-green deployments, dark launches, feature flags, and deployment rings are essential for managing risk and ensuring smooth rollouts. By gradually exposing changes to users, we can identify and address issues early, minimizing impact and ensuring a better user experience. Depending on the tool you use to implement DevOps, it may dictate the naming convention of a common DevOps concept to provide automation of your CI/CD. Both Azure DevOps and GitHub Actions provide robust CI/CD capabilities, but they have different structures and terminology. Azure DevOps, in the top left, uses stages, jobs, steps, and tasks to organize and control the pipeline, while GitHub Actions, the bottom right, relies on workflows, jobs, steps, and actions to achieve a similar functionality. In the context of GitHub, the term action actually has dual meaning. The first one, the capitalized action, represents the GitHub services, which provides the ability to implement CI/CD workflows, which I just described. The second one, the lowercase a, describes a reusable unit that can be included in workflows to deliver a specific functionality, such as running a script or executables, building and uploading artifacts, or setting up access to an Azure subscription. What is depicted on the screen are actions that are part of a deployment of an IaaC infrastructure. GitHub Actions are a powerful tool that allows you to automate your software development workflows directly from your GitHub repository. It also integrates seamlessly with your existing tools and processes, making it an excellent choice for implementing CI/CD. GitHub Actions is a continuous integration and continuous delivery platform that allows you to automate your build, test, and deployment pipeline. You can create workflows that build and test every pull request to your repository or deploy merge pull requests to production. A GitHub action workflow can be triggered either manually or automatically. A workflow is made up of one or more jobs that can be run in parallel or sequentially. This will depend on the runner or runners they are running on. As a side note, a runner is a server or VM that runs your workflows when they're triggered. Each runner can run a single job at a time. GitHub provides Ubuntu, Microsoft Windows, and macOS runners to run your workflows. A job is made up of one or more steps, and a step is made up of one or more actions which performs a specific task within a workflow. Actions are the building blocks of workflows and can be used to automate tasks such as building, testing, and deploying code. Variables in GitHub Actions are used to store non-sensitive information that can be reused throughout your workflows. They help in managing and reusing values that might change depending on the environment or context in which the workflow is running. Variables play a crucial role in making workflows more dynamic and flexible. They allow you to define values once and use them multiple times across different steps, jobs, or even workflows. This reduces redundancy and makes it easy to update values when needed. Secrets in GitHub Actions are used to store sensitive information, such as API keys, passwords, or tokens. These secrets are encrypted and can only be accessed by workflows that have been granted permission. Secrets play a vital role in securing sensitive information and ensuring that it's not exposed in your workflow logs or code. They help in maintaining the security and integrity of your workflows by keeping the sensitive information safe. Continuous delivery in GitHub Actions allows you to automate your deployment processes, ensuring that your code is always ready to release. By defining workflows, jobs, steps, and actions, you can create a robust CI/CD pipeline that integrates seamlessly with your existing tools and processes. Microsoft Defender for Cloud and GitHub Dependabot enhance the security of your continuous delivery pipelines. These tools play a critical role in identifying and mitigating security risks and ensuring that your code is secure throughout the development lifecycle. Microsoft Defender for Cloud is a comprehensive security solution that helps protect your cloud environments, including your GitHub repositories. It provides continuous monitoring, threat detection, and security posture management to safeguard your code and infrastructure. Microsoft Defender for Cloud continuously monitors your GitHub repositories for suspicious activities and potential threats. It detects compromised accounts, insider threats, and data leakage, providing real-time alerts to help you respond quickly. It offers insights into your security posture by identifying vulnerabilities and misconfigurations in your code and infrastructure. It helps you maintain compliance with security standards and best practices. By connecting your GitHub repository to Microsoft Defender for Cloud, you gain visibility into your users' activities and security events. This integration allows you to enforce security policies and protect your code from malicious actors. GitHub Dependabot is a native feature of GitHub and helps you keep your dependencies up to date and secure. It automatically scans your repositories for vulnerable dependencies and provides alerts and automatic pull requests to fix them. Dependabot alerts you when your repository uses a dependency with a known vulnerability. This ensures that you are aware of potential security risks in your codebase. Dependabot can automatically create pull requests to update vulnerability dependencies to secure versions. This helps you quickly remediate security issues without manual intervention. Dependabot integrates seamlessly with your existing GitHub workflows, making it easy to manage and secure your dependencies as part of your continuous delivery pipeline. In this module, we focused on continuous delivery, or CD. While CI focused on building and testing software artifacts, CD automates the process of delivering these artifacts to users. Continuous delivery involves automating the generation of software releases, ensuring they're deployable and making them available to consumers. It aims to minimize the time to deploy and mitigate issues. Continuous delivery is an iterative process that involves transitioning the latest software releases through different environments for testing and validation. The main takeaways from this module are that continuous delivery offers several benefits, including accelerated release cycles, increased resiliency, improved collaboration, and efficient resource utilization. It allows for faster deployment of software releases and enables organizations to gather customer feedback gradually. Progressive exposure techniques such as deployment rings, blue-green deployments, feature flags, and dark launches continue to increase resiliency in continuous delivery practices. Additionally, GitHub Actions are a powerful tool for implementing software delivery workflows on the GitHub platform, allowing you to build and run CI/CD workflows using various components. I hope you've enjoyed this module, and I look forward to seeing you in another module.